Right. Okay, I'm gonna go over page 190. Oh. Hello? Did I do it again? I thought I turned it off. Is there two? That's why. No. That's off. That's off. Okay, so what the heck? Hello? Hello? Where the heck is that coming from? No! What? I turned it off. Hello? I know. This is weird. Okay, stop. Hello? Hello? I haven't had this. Turn this off. I don't know. Give me a couple minutes to figure this out. Is it feedback from the projector? No. Hello? Something like this. Hello? No? Oh, sure.
How does a feedback loop like eventually end?
When I destroy the machine and throw it against the wall.
But like eventually would it like keep on going? Like have like microphones attached to speakers.
Yeah, this is recording. So this, it's the iPad. Hello? Stupid. Okay, hello, hello. No, nothing, right? Unless they change the algorithm, right?
Al Gore invented the algorithm.
Did he?
Yeah. He also invented climate change.
Okay.
Well, many other things.
Hello. Hello.
Democratic candidate Al Gore.
Hello, hello. Okay, so now there's no feedback. Okay.
Democratic candidate Al Gore. The algorithm causes climate change. Me going back in time to shoot Al Gore to prevent him from inventing climate change.
Okay. Page 190, number 1. Yeah, just read it again. Read it again. Let's do the calculation. So we have the first object mentioned is our 1400.
Australia, I don't think they're attached to the projectile.
Any of that. Better?
Oh, yeah.
Calculate our momentum for object 1. It's 1400. I'm going to use kilometers per hour. Yeah, I know you can convert to meters per second if you want, but it just saves a step. Okay. I'll drop the unit is different now. It's kilograms kilometers per hour, but regardless. 2,000 kilogram truck. Moving at 35 kilometers per hour. Okay. So they stick together after collision. So we have, it's a collision, so we can write this down. There's two objects, there's two terms. So when it's a two-dimensional problem where they're hitting, in this case, one's traveling west and the other one's traveling north, we know that this equation is going to reduce to three terms. In this case, on the right side, they stick together, so I can simply write P1, where P1 is equal to the total mass times the velocity of the car and truck as they move off together. I'll rewrite this. You got P1 plus P2 is equal to P1 or P prime. Okay, now let's draw this in terms of arrows. Let's draw that out. So I have my P1, which is moving towards the west. That's my P1. I'm gonna need room because I've got it here. This last one. It's my P1, and then my P2 is headed north. So this is my P2. They're added tip to tail. And they add together to give P prime. Yes, this is going to all lead to a right angle triangle. P prime. But the angle at the tail. Right angle triangle. Okay, I'm going to replace the P1 and P2 with numbers. Actually, I just lasso it. Right, I'll replace the P1 and P2. So P1 is this. $5.18. And my P2 is my 7. It's 10 to the 4. Yeah. Like this?
Yes.
The proper unit is meters per second at the end, but we use kilometers per hour, so. And the V, if we go back to this, that's what we want. We want the V prime. Total mass. What did I say M1 was? M1 is 1,400 plus 2,000. That's how you get the V prime, which gives you an answer in kilometers per hour. You can leave it in that if you want. To convert to meters per second, divide by 3.6. I don't have an answer to that, but
7.1.
is it 7.1? Okay, I'm not done. I need an angle. North of west. You could put 10 to the 4 next to it if you want, but it cancels out, so. $36.5. What is that? 3.5. So 40, 50 minus 3.5. All right. That's 50. No, 56. It's not right. 53.5. 6, 9, 10, 69. Yeah, that's it. And then that's north of west. Okay. Time is at 23. I do want to, okay, we'll have time. Let's go over, I said you're going to do 1 to 4. Do 2 if you haven't already done it. You want to skip 3, make space for it. You're going to come back to it. I'm going to go over 2 and 4. 2 and 4. So you're already working on 3, great, but if you haven't got to that point, you can do 2 and then skip 3, come back to it. I'm going to look up something for you here.
this entire expression for VT final, so that gets multiplied by VG final, the final velocity of the golf ball, minus the expression here. Because we have this one, we do not have to plug conservation of momentum into conservation of energy. That would square the term we put in. That would get nasty. Elastic collision. So this expression right here only holds for elastic collisions. But you should love this formula right here, because what this does is it allows you to avoid having to use conservation of energy and avoids having to square terms and create horrible messes of algebra. This formula is going to be much cleaner, much nicer. Let's see how to use it. Let's just say object 1 is the tennis ball and object 2 here is the golf ball. So in that case, the initial velocity of the tennis ball, that'd be 40, and it'd be positive 40. I'm going to write positive just so I know that's to the right, and it should be positive. Plus the final velocity of the tennis ball, I'll write that as VT. So instead of writing 1, I'm going to get confused. Number 1, so I'll write a VT. That way I get to know which object's velocity I'm talking about. So VT final, that's what VT final is going to be, final velocity of the tennis ball. And that should equal the initial velocity of the second object. If our second object is the golf ball, the initial velocity of the second object of our golf ball is not 50. It's negative 50. You got to be careful. These are velocities in this formula. So if you've got a velocity that's directed in the negative direction, you better make it negative. And if you solve in here, you might get a negative. So these are...
Didn't know that. Huh. Shoot.
What's the math of that? This would be 1D, right? So like this would be one dimensional. Equation. Okay, no, that's not. I can't actually find the equation how it's going to sound.
Done? Yeah, there's a lot there. I'll start going over it, at least number 2 in a few minutes here.
300. Super. As the P 52 6. It is a oh yeah, because it has to be momentum. Oh, great. 6 times 50 times 6.
Hmm. You have guys, can you just calculate 33.6 divided by 14.2?
2.4.
Yeah, thanks. Thanks. Yeah, I did number 2 for you. I'll post it in a sec here. Okay, for number 2, you have two objects that collide, that are moving perpendicular to each other. One is moving north, one is then moving west. They collide, and then they move off together. They stick together. So I calculated the momentum of each. And I wrote down my equation. I simplified it. The expressions on the right, the two terms on the right cancel out. Cancel out. They reduce to P prime. They reduce to one term because the objects collide and stick. So I represented visually that equation above. That's my triangle. It's a right angle triangle. The sides 18.6 and 28. I used the Pythagorean theorem. I got my final momentum is 33.6. I then solve for my velocity. Velocity comes from this equation up here, right? The final momentum is equal to the total mass times the final velocity. Okay. So we get velocity of 2.4. I'm not finished. I need to calculate the angle. It's always drawn at the tail of the resultant. It's 65 degrees west of north. I'll do number 4 for you. When you've finished number 4, I'll go over that next. I'll write it down. You guys can check it in a minute. Anyone finished 4? Oh, brilliant. If you finish 4, you can, I've got an assignment for, it's just linear momentum. You can start working on that. It's your option. That's going to be due Thursday, or you can review for the test. So, yeah. Really? You probably, did you use 28 over 18.6?
Yeah.
So maybe my answer key's wrong. Okay. So it is 56. One sec here. Where did I copy it down from? Yeah, 56. Thank you. I reversed the numbers. I think I've got a little dyslexia today. Just fine. I'm not making fun of that. Just saying. I'm going to go over number 4 in a second. I'll do 4 separately. Guys, just work on the handout. I'm going to give this to you now. You can work on this. This will be your assignment. The answers are on the page. You can check your answers. I wouldn't do it on this. It's too small, guys. I have some people who do that. They write microscopically. Don't do that. Write on a separate paper.
What will like the next test be like after Wednesday?
After tomorrow, I'll let you know. It won't be Friday, unless you want Friday. It'll be Monday, but let's deal with one test at a time.
They don't show the process yet. Also, it's 491.
This is linear. This is actually, this assignment's not too bad because there's no 2D. I see you expanding it. Okay. You guys are done. Yeah. Okay. Yeah, it's, this, these two add up fine, so I give you half mark for that. But this is at an angle. Well, is that what you did?
That's basically like
Oh.
against like
Oh, I see.
the friction of gravity.
Okay, give me that. Yeah, you don't have to do that, but it's still works. That's why it threw me off.
That's like
Yeah, that'll be due Thursday. Interesting. Okay, it works. Let me just make the correction here. Yeah. Yep. If I pull this up on my ed, does my ed recognize you? Should do that. Hello? Oh, crap. How? Just shut up. You're a piece. Hello? No. No. Don't want that. Hello? Hello? Okay, so I do that. Okay, that's what's screwing it up. Interesting. Austin, can you just grab it for me, please? I gotcha.
Thank you.
You're welcome. Finish obviously number 4 first before you start working on the project. Let a project assignment. Yep.
So I was wondering if I have like all the topics for the test tomorrow. So tomorrow we have Newton's three laws,
Yeah.
inclines,
Inclines, and then
friction.
I added that in. Yeah, and then friction, right?
Inclines also have an angle. Free body diagrams.
Yeah, definitely you have to include that with the written problems. So
Okay. Elevator questions.
yeah,
Forces at an angle. Okay.
that's that.
Am I missing anything?
That's it. Just remember what. Yeah, that's it.
That's it. Okay.
Remember with the incline problems that it will include possibly kinematic question as well to it, like how far down, how
And we'll
fast.
also get like a sheet with all the formulas in there.
Yeah, I'll just copy the same one as I used before.
Okay. Thank you. I'm just tell you.
Yeah.
What? For Newton's three laws, like do we just state
Just
them?
state it. That's an easy question. That's like a gift.
Okay.
Yeah, but you got to get it precise, right?
Equal and opposite reaction.
Yeah.
Question 5 from that. Franco, why?
Yep. We may go over it later, but not asking you to do it now. Hey, Susan. One second. I'll draw this. So what was that? Oh, you don't know how to do it with friction? Oh, okay. So I'll just. So this is not a free body diagram, but this is just a diagram of the forces pulling on it, causing it to move down. That's FG parallel, you know that. Acting against it is friction. So that's going to give you your net force.
Wait, what? Really?
Now, the question, what's friction? Well, here,
What you do is scalps.
I derived these. I would just mg sine theta, FG, or which is mg. And friction is just,
Why did you?
there's a cosine instead of sine with the mu in front.
Well, in military,
I derived that as well.
defense.
So that's what you plug in there. And there. This is all equal to MA. You'll find the masses cancel out.
Why?
You plug that in there. You plug this in minus this here. And then I'll write it out. MA
Like, you show up, like, basically,
mg sine theta minus what I did. I inserted for this, inserted that. This, like that. Minus the friction, which is that. Oops, so G. Cosine instead of sine. There's an M there, an M there, and there. In math and algebra, you had like a 2 there, a 2 there, and 2 there. You could divide it out. I mean, cancel it out. That simplifies it. That's your A. A is equal to G sine theta minus the coefficient times G cos theta. That's it. Yep. You're welcome.
That'd be cool. Like Marvel School is a teacher's school. Everyone so
Wait, now I'm just talking. It's the wrong formula.
force equals mass. What is this supposed to be? Um. I actually don't know how to do this. Force equals mass. How do you calculate force again? Or it's like massive velocity? That's like momentum.
Yeah.
My mind's like doing this. Are you supposed to calculate momentum, like change in momentum? Because that's what it equals.
Yeah.
No, but then what is average force? Force equals, um, one. Oh, you're supposed to find acceleration with this? So I took it, you like, and then I changed it with my force. Change it on momentum. And say about this. Change it on momentum. Force times time equals change in momentum. Okay, I can find change in momentum. I have, I can find it. That's force. Is that it?
Yes.
Oh, it's like
Is
the-
this Simon due on
Five
Thursday?
change in
Yep.
momentum.
Mm-hmm.
Like time, and I find it. Okay, average force. I think that's the average force. So, is it kilo supposed to be 1,000?
Oh, yeah, this is in grams.
Yeah, 1,000 grams is 1 kilo.
Anyways, on Sunday, it just goes like. What? 7 meters per second. Is the velocity.
Oh, yeah.
Last time velocity was mental.
Is it mass times acceleration?
This force.
Mm-hmm.
I want to understand, two dimension again.
I'm gonna go over this one. 4A, just wrote it out, so I'll go through that with the class and then see if that helps a little, and then we can go over further if we need to.
Anyways, we take some like so yeah, but then like we found like this like it's like a local track. I know like railroad tracks, and I don't know how railroad tracks and I go like in there everywhere. And next to the tracks. I think there was like doing like repairs on it, but back and we left the bunches like
Hello? So why is it doing that?
like nothing. They just left like a dozen like railroad spikes and like just like little things and everything. Anyways, it took like railroad spikes. But it's just like stuff that's going backwards. Every force has equal and opposite. So how much is going forward is how much is going backwards. So force equals mass times.
It's still recording the sound. I don't, why? Why? Oh, okay.
I did see the phrase.
Hello?
Force equals mass times. That's not. So 34 kilograms times 778 equals
Yeah.
1,400 kilograms times X.
If
pounds.
the mass of the rocket is chemical concept used to predict the recoil speed of the rocket. I think you need the mass of the rocket, that's why.
Oh, it's force net.
We need the mass of the rocket, yeah.
6.9.
Hello? Hello? Hello?
Anyone there?
Yeah, yeah. Hello? Hello? Hello?
That's the momentum. That's like that's the yeah.
What are you doing? Hello? Hello. 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 Hello, hello. That's better. Turn the volume down. I guess that's the key. Anyway. Okay, so for number 4, just went over it. You've got a 5 kilogram that's moving. It should be slightly east. It's not directly east. We find out later it's at a slight angle. The second object's not moving to begin with. Stationary. So that's why I cancel out P2 here. And then when they hit, they move off in different directions. One's north of east, the other one's south of east. So I calculated the momenta, the P1 and P2 after the collision, 300 and 378 respectively. And then I found their components. The X components in red, Y components in green. You know how to do that. This second angle here is 38. I then added the red components because they're in the same way. They add 193 plus 298 adds to 491. Then I subtracted the green components, very similar to what we've done before. The 233, subtract from that 230, you're left over with 3. And that green and the red vector left over make up the right angle triangle, where P1 is the hypotenuse. P1 is the opposite side is so small. P1 is essentially the same. Oh God. I keep doing this. I'm talking to myself, man. It's okay. Okay, let's go back. So 4, the P2 cancels out. Because it's stationary, we're told that. I then calculated the P1 and P2 after the collision. I highlighted that in a purple rectangle. I then broke those vectors. P1 is at 50 degrees. P2 after the collision is at 38 degrees. I broke those up into its X and Y components, the red and the green. So the 2 red are going to add since they're in the same direction. 193 plus 298 is 491. The green are going to subtract because they're in opposite directions. You're left over with 3. 233 minus 230 is 3 for the Y component, for the green vectors. Those, whatever's left over makes up the sides of a right angle triangle that give us P1. So I found P1. The opposite side is so small that P1 is essentially the same as its X component. I divide by the mass of 1. It's about 10. It's 9.82. Found the angle. Angle should be pretty small. It's pretty small. It's 0.35 degrees south of east. Okay, I haven't done the elastic collision test yet. I'll do that next. Give me a minute. Keep working. Oh, gosh.
Yeah.
I'll show you how to do part B in a second. I'm just completing it now. So you can work on your assignment still.
Bolson was off first, 12.64.
Oh, yeah. What's on?
Right. Okay, so are you going to the OR for tomorrow? Like, why not?
It's really far.
Do you not look like you go in Moscow?
I do not live near Moscow.
No.
I still walkable.
No. It's so good to walk home. You'll be dry by the time you reach home.
Not even one drive.
Tomorrow, I'll do the test, and I go home. I'll do the work, and I will just run, like 2, like 1, 1, sack of water.
Okay, let's look at part B. So I tested the statement, does the kinetic energy in the beginning, does the total kinetic energy in the beginning equal the total at the end? I calculated the total on the left, it's 2,410 joules. On the right, it's less, it's 2,100. So it's not elastic. It's inelastic. It's not elastic. And the difference in the two will give us whatever energy is lost in terms of heat, thermal energy, 310. Now, I neglected to load yesterday's class on YouTube. I want to get to that now. So, everyone got this? Do I need to keep it up a little longer? Yeah, some people. Give me a minute. Does that sound like a bass guitar? Someone's playing. Keep it up for a minute here. Okay, so I'm gonna download yesterday's video. Everyone got it? Susan, you got that? Anything else?